Hey guys, before we go to chapter 3, any question for chapter 2? If no, you can say no, you can type no. Yes, you can type question or unmute. Oh, no one is here? Or give your thumbs up. My question is any question for chapter 2? Okay, all right. Okay, so chapter 3 is something not new because it's very familiar. Yeah, thank you, Rabiatu. For chapter 3 would be functions. Okay, now we need to have a map as a function. We need to have a set because a function or a map has to go from one set to another set. Okay, so I will write out the formal definition of the function. Okay, let x and y be non-empty sets because we don't want our set to be empty. Okay, a function f from x to y denoted by f from x to y is a relation. Is a relation from x to y, because before we have relation, right? Such that for all x in the domain of f, that's the keyword, yeah? For all x in the domain of f, fx is called the f relative set of x. Contains just one element of y. Okay, so we want to write this whole sentence in one line of symbols. Okay, we write f from x to y for all x in x. How do you say this? Shakila, how do you say this?
I forgot, doctor.
How do you say this? They exist? Not they exist because there is a this means unique, yeah? This means unique. There exists a unique. Jangan jerit pula. There exists a unique y in y. Okay, such that xy in f. Okay, so the keyword is for all. And for each of those, there is only one image, meaning from one x cannot go to 2y, right? And this is in f. So we used to write this, right? In school last time, right? So if you have all these elements of X, some element of Y, don't need to be the same, right? You have to have one out from each, one only out from each. They can share, right? But you cannot have two out. This is a function. This is what it means, yeah? For all X, yes, for all X. And there is a unique Y for each one, okay? You cannot have two out. Okay, this is a function, this is okay. You cannot have like this. This, then this, and then like this. Okay, this means you have two images for one X. This is not a function. Okay, we know, we learned from school, right? For relation, we have one-to-one, one-to-many, many-to-one, many-to-many. But from those, only two is a function, which is one-to-one, and then many-to-one, right? But you have to cover all the domain. Okay, so this is what it means by a function. Let me draw some. Okay, before this, let me, where is the one-to-one and on-to? Shiham, later on you help me to remove the not one-to-one and not on-to in the beginning. For example, 3.1. Actually, that comes after. That was my draft last time. Before I go to one-to-one and on-to, let me give you some examples. Yeah. So today I will call someone that I see just the name, not the video. Okay. All right. Okay, so I will give some examples. Hey, why? So I have from X to Y. I didn't look at the examples in the notes. They might be similar, but Okay, so I will call some names from the second page. Okay, Usama, are you here? Usama?
Yes, doctor.
Yeah.
Sorry.
Okay. I want to know whether this is a function or not.
Sorry, what?
Is it a function?
Mm, mm,
Is it a function?
hold on. I don't think so.
Why?
Because there is no function. Because the function. How do I phrase this?
See?
3
You
does
understand the
not.
hard to write
Yeah.
the function, right?
Yes.
This is how you write it. One way to write it. No, since you want to say this, there is no image for 3.
Yes.
Right?
There is an x that exists.
There is no image for 3. So there is no y in y. There is no y in y such that 3y is in f. This is actually the function f. Or you say 3 has no image in y.
Okay.
I can understand you know how to reply, but how to write, but write out something. Okay? But
Okay.
symbol is like this. Since there is no y in y, you can write in words also. Such that 3, there is nothing, right? Because there is no coming out. 3y is in f. Okay. Or sometimes we write there is no y in y such that f3 is equal to y. You can also write that. There is no y such that f3 is equal to y. Okay, it's not a function. Okay. Because this word, for all x, right? The domain is not all x. Sometimes you can say like that too. The domain is not the whole x. Okay. But this is better. Okay, next sitting to Osama in my Zoom is Ahmad Shakir. Ahmad Shakir, are you here? Ahmad Shakir. If you are not here, meaning, okay. Yes or no? Is it a function? Yes, okay? Yes. If it is a function, you can just copy this. You can just copy this. Because 1 has one image, which is A, 2 has one image, which is A, 3 has one image, which is A. Easy, right? Just yes, and copy. Yes, since for all x in S, that is in Y. Okay. Number 3. Nurul Diana. If your internet is okay, it would be nice to see your face. Saya ni susah sikit matchingkan nama dengan muka. But it's okay. Nurul Diana, are you here?
Yes, Prof.
Okay, is it a function?
No,
No, why?
because
The easy way is to say since 2 has
two,
2 images, yeah?
yes.
Or is the image of 2 is not unique.
Yes.
Or the image of 2 is not unique. Either one, as long as I know what you mean. Sometimes it's hard to write out the reason, but most of the time there is a mark for that reason. I normally will put M1 for the method, A for the answer. Okay. Okay, everyone else is okay. If you don't understand, ask me. Kong Zijing. Kong Zijing.
Yes, Prof.
Okay. What about this?
It is not a function because 4 does not have an image.
Mm-hmm. Right. The same thing as this, right? Okay. So I won't ask because the same reason here. Okay. Akmal Buhari. Akmal Buhari. Are you here? Okay, Akmal. Oh, tak ada, attendance kena tolak. Akmal, wake up. Okay. Nor Salwanisa. Hana, you take note nama yang saya panggil ni. Nor Salwanisa.
Yes, doctor.
Okay, yes or no?
No.
No, reason is the
Not
same
to
as
image.
this one. Siapa tepi dia tadi? Afif, Muhammad Afif. Yes or no?
No, no, that.
Hmm?
No,
No, why?
it's because B.
Because B has nothing. The answer is yes.
Yes.
You only look at the X part. Okay, doesn't matter if there is something on the right which is not mapped. Okay, you only look at the left part. Everything has to have an image. I didn't say everything on the right has to have something mapped to it. That is not onto actually. Okay, understand? Afif, okay? As long as there is one out here. Okay, and so this is also yes. So this is all very basic that you should know. Everything from the left has to be mapped and only one out. That's the key, yeah? Anyone has to be mapped and only one out. This is 2 out, that's why it's no. This is not all mapped, so it's no, right? Okay, now we look at all those functions and see whether they are one-to-one or onto. Okay, one-to-one means if fx is fy, x must be y. If you have, you cannot have like this is fx is fy, right? Fx is fy because you have 2 here, but x is not y. It's 2 different things mapped to 1. Okay, you cannot have that. So this is not one-to-one. This is okay, one-to-one. This is not, right? Because you have this fx is fy, they're all here, but they have come from 2 different ones. One-to-one is actually easy to see, just one-to-one. Okay. And onto means if for all y in y, just now for function is for all x in x. For onto is for all y in y. There exists x in x, which is mapped to that y. For all y in here, it has to be an image of something from x. So you look at the yes, okay, here. This one is not an image of anything. So this is not onto. Okay, look at the yes, yeah? Look at the yes, okay, here, not onto. Because there is no, this is not an image. And this is no, right? Not onto. Because this one, there's 2 different one, goes to 1. So to be one-to-one and onto, you have to have the same number of elements, left and right, so you can match up, right? Nicely. Okay. there are some other ways to determine whether a function is a mapping is a function or one-to-one or onto from the graph. Okay, so here I put here vertical line test and horizontal line test. For example, okay, let me write a few. It might be here or not here, but let me just write out some, yeah. Like this, right? X, Y. Okay. Let me put and then you draw. This is all the basic function that you should know. I haven't drawn this for quite a while. And then you can move left and right, up and down. That's one more, maybe fx is squared and fx equals x. Okay, so x squared, right? X, right? Touching the zero. Then it's cube. Touching the zero, it's cube. This one you have to move a little bit to the one, right? So you move to the one. And when x is 0, y is 1. So touches. This one is like this, 1 over x sine x. So you have one complete one in between 0 and 2 pi, right? Another one between 0 and 2 pi sine x. Cosine, you have how do you draw a cosine? And tangent. Cosine, complete 2 pi, right? So 0 is pi over 2. and tangent. Tangent is okay, and you complete this. Okay, so this one x cannot be 0, so that's this, right? So it goes like this when x is negative and x is negative, 1 over something squared, right? It goes, so the difference between this and this, you can see it's flip. Okay, and tangent cannot be, tangent is sine over cosine. So whenever cosine at here, you have to have that, right? Then you go like this. All right, and last one. Okay. Ada silap tak? Is it okay? The okay is a magic word. You heard the okay, you need to give me reaction. Gelap. Okay. All right, so the question is it 1-to-1 or onto? Now, but first you have to know whether it is a function or not. Okay, so to know whether it is a function or not, you do the vertical line test. If the vertical line test connects only at one point, meaning it is a function. Okay. If the vertical line test go through more than one, that means it's not a function. I put number 11 then. So x squared plus y squared equals 1. Okay, this is, that is the graph of a circle, okay, in which the center is 0, 0, and the radius is 1. Okay, so if you do vertical line test, you just draw any vertical line test, any vertical line, it only intersect at one point. Okay, that means it's a function. If it intersect at more than one, it is not a function, because that means with 1x, you have 2y, right? With 1x, you have 2y. Another way is if you flip this the other way around, x is the, right? Then you will have that, which is not a function. Okay, these are all function except for this one, right? How do you know it's 1-to-1? Is by drawing horizontal line. If you draw one horizontal line, it intersects at more than one point, meaning it is not 1-to-1. Okay, so let's try. So this one, when you draw the horizontal line, it intersects at 2 points. Okay, intersecting at 2 points means there is one y for 2x, right? You go like this. From 2x, you go like this. So this means it's not 1-to-1. Don't put that as a reason. Okay, the horizontal line test is intersecting at 2, so it's not 1-to-1. That is a way to check, but your reasoning has to be because 2 and -2, they have the same image. Okay, you cannot have the same. So this is a function. which is not one-to-one. For onto, it depends on whatever the x and the y is given to you. So you have to look at the question. Okay, if the question say f is from R to R, then this is not onto because it covers the whole y-axis. Okay, but the graph is only on the top, so it does not cover the whole R. There is nothing here. Yeah, so in this case, it is not onto. So onto depends on the question, what is given to you with the y. So this is the same, not one-to-one. This one is not onto if it's f from R to R, because 0 is not an image. Because 0 cannot be an image. There is nothing, no x, such that 1 over x is 0, right? And it does not also cover the whole thing, but it is one-to-one. It is one-to-one because you draw, you won't get intersect. Okay, so this one is one-to-one and also onto because it intersect at 1 and the horizontal 1, and it covers the whole of the y-axis. Okay, because if the question is like from R to R and the graph cover the whole, but I can change the question. If I change this question into f is from R to R bar, okay, in which R bar is equal to R plus union 0. This means it is a non-negative number, non-negative number. If I don't put this, that means a positive, right? But I want to include 0. So I call it R bar, R plus. Now this becomes onto because it covers from 0 until on top. So it's a little bit tricky in the sense that you really have to check whether the y covers this or the x and y. All right. For this, it's not one-to-one because some of the x get the same y, right? Even for this particular one, you draw, there are so many, right? There are so many x from the left-hand side, which is mapped to the same y on the right-hand side. This one is not one-to-one, okay? But it covers the whole, so it's onto, right? This one is not onto if it's from R to R because it's only in between, 1 and -1 only, right? The range is only in between 1 and -1. It didn't go beyond that. So, but if I ask you like this, if I give you that range, then this is onto. Okay, so you cannot just put in general, this is onto, it depends on the x and y. So you have to really look at the question. Okay, so this is not one-to-one. For this particular case, it's onto. This is just now not one-to-one, but onto. This one also is not one-to-one and depends again, right? If the question is this, is not onto. If the question is this, it is onto. So it depends on the question for the onto. This is not a function. Again, this one, this is not one-to-one and also not onto because it will never reach 0. It depends. But this is depending. If I put like this, f is from R to positive. Okay, f is from the whole range of x until R plus. You see, R plus is on top and it covers the top quadrant, right? It becomes onto. So it's, I cannot just give a general is onto or not, because it depends on the domain, and the codomain. All right, so I can give you so many other examples, but you can decide. Okay, you can decide, but to write out the answer, the reasoning, like this one, why is it not on one-to-one? Because you can say F1 equals F negative 1 equal 1, just 1 squared, right? 1 squared and negative 1 squared, but 1 is not equal to negative 1. So this is actually the right reasoning to put that it is not one-to-one, matching the definition. Okay, 2 map to 1. Okay, let me see. Let's see. The last part. Is it the last part? Are you taking modern algebra now? This semester or last semester? Gini. Can you unmute, Sneha? Can you reply
Modern
that?
algebra elective SEM ni.
Okay, so some of you taking it.
Yes.
Okay, those who taking modern algebra, can you show your, I want to see how many. Show your reaction. Okay. Okay. Not all. Okay. Banyak sangat ni thumbs up. Okay. Give this reaction. Look at my reaction. If you don't take it. Wish, ramai juga tak ambil. Okay. Oh, it's elective, yeah? Okay, it's okay. It's okay. For those who are taking it, then you probably have kelebihan lah, yeah? If you will see this for the second time. But I will explain this as if this is the first time you see this. Okay, I will go into the permutation. Yeah, permutation. I think next year it become the core. Yeah, modern algebra. Okay. Okay, so permutation. All right. So if a function is one-to-one and onto, it is called a bijection, right? Bijection. Okay, so if you get a question, show that this function is a bijection. Jangan terkejut lah. You just have to show it is one-to-one and onto. Okay. Now, the definition of this is a bijection from a set A to itself. So you cannot have like from X to Y. It has to be from X to X or from A to A. Okay? It's called a permutation on A. A permutation on the set. Okay, so this means one-to-one and onto. All right, so a permutation is if X is equal to Y or A is equal to B, and it's also a bijection. Okay, now let me go through an example, right? Let A be one, oops. Let A be a set of, if one, there's nothing, right? If you have two, think about this. Okay, A. Think about this. The only way to map 1 to 1 and onto is to map 1 to 1, 2 to 2, or 1 to 2, 2 to 1, right? That's the only way. Okay. Then we write P equal, I want to make sure it's the, because sometimes I put bracket. 1 okay, like this. 1 goes to 1, 2 goes to 2. This one, 1 goes to 2, 2 goes to 1. So this one is the X, this one is the Fx. Okay, the first row is the X element, the second row is the image. Okay. Now we go to the second example. Let A be 1, 2, 3. How many? How many? So the first one, call it F1. It goes to itself, right? It goes to itself. Like this, it goes to itself. The next one, you fix one, change the other one. Okay, I fix one. This is still 1 to 3. I fix one, I switch the other two. So 1 goes to 1, 2 to 3, 3 to 2. Okay, fix one. So I fix this one, I do this. Still 1 to 1 and on 2, right? The third one, I fix 2. And then you switch. The fourth one, I fix the third one. Then you switch. Habis dah eh? All we have fixed. The fifth one, I change all, right? Change all. 1, 2, 3. 1 goes to 2. It's like 1 goes to 2, 2 goes to 3, 3 goes to 1. 1 goes to 2, 2 goes to 3, 3 goes to 1. The last one, the last one, 1 goes to 3, right? Just now it's 1 goes to 2. 1 goes to 3, 3 goes to 2, 2 goes to 1. Okay, so I have 6. And in short, if we have n elements of A, then we have n factorial number of permutation. Yeah, we call it S sub A or S sub n. The number of permutation, S of A, or just in general S of n, if the order of A is n. The next one is, this is called in matrix notation. The other one, we call it cycle notation. Okay. For the cycle notation, we will write in a cycle, not in a matrix, and it will save space. Like this one, identity is always 1. Although you can write like this, but identity is given just a cycle around 1. This 1 goes to 2, so you put 1. I always put the smallest one first. 1, and then go to the right. Go to the right means is the image, yeah? 1 goes to 2. And then where does 2 go? You go to 2 here, 2 goes to 1. So this. So this means when you read this, that means if there is a 1, 1 goes to 1. There is a 2, 2 goes to 2. If you have like this, 1 goes to 2, 2 goes to 1. So that is cycle go around. So you will write this as 1, right? You write this as 1 to 1, 2 to 3, 3 to 2. 2 to 3, and then 3 to 2. This, just 1, 3, right? The 1 goes to itself, we don't write. If you see it missing, meaning it goes to itself. This 1, 2. This one, there's nothing that you fix, so you have to write all numbers. 1 goes to 2, you put 1 first. What is the image of 1? You want to write on the right. The image of 1 is 2. Then now you look at 2, you want to find what is the image of 2. 3. Then you look at 3, what is the image of 3? 1, but 1 is already here. So you close that. And then when you draw, it's like this actually. 1 goes to 2, 2 goes to 3, 3 goes to 1, 1 goes to 2, 2. Right? And this one is 1, which is goes to 3, 3 goes to 2, 2 goes back to 1. So by all this, we can write the permutation of S3 to have 6 elements. Six of them. Okay. All right. The next one is how do you multiply permutation? Yeah. How do you multiply permutation? Okay. Right. I will show you 2 ways. Yeah, I will show you 2 ways. One is by matrix notation, and one is by cycle notation. Cycle notation saves time to rewrite, and it's much simpler in the sense that you don't have to repeat and write the first row in the matrix all the time. Okay, for example, product of permutation. Let's see, let's multiply F2 with F5. Okay, multiply in this sense is actually taking composition, right? When we do function, we do composition of function. When 1 goes to 2 and then 2 goes to where? But I will rewrite the F2 1, 2, 3, 1, 2, 2. And 5, 1, 2, 3. Those who taking modern algebra, which chapter are you now? Guys, which chapter or the name of the chapter? Lupa. Ya? Siapa tadi yang ambil modern algebra? Which chapter are you now in the class?
That's done with permutation.
Just done with permutation. Okay. Because permutation is chapter 4. Yeah? All right. So this is a review for you, but for the one that's not taking it, this is the whole of the notes that you have to know. Okay. So you start with 1, 2, 3. Then you go from left. Let me see, left to right or right? Wait, make sure. 1, 2, 3, 3, 2, 1, 2, 2, 2, 2, 1, 2, 2. Okay, from right to left. Different authors, they use a different way. We go from right to left. Right? Two. Okay, so goes from 1, yeah? 1. 1, the image is 2. Okay, and then you look at 2. 2, the image is 3. So you will put 3. Okay, you can complete. You go to 2 now. 2, the image is 3. Then you look at 3, the image is 2. The third one, 3 goes to 1, and 1 is 1. So make sure it's 1 to 1 and on 2, so it's 1, 2, 3, and also the numbers you don't get multiple, double. And you see that is actually F3, right? So it's actually close in the sense that you will get one other member in there. Okay. This is using matrix notation. You can also find the product using cycle notation. Okay, so this one, F2 is 2, 3. And we multiply by F5, which is 1, 2, 3. Okay, so let's try. And F3, we know it's 1, 3, right? You know the answer. Okay, anyhow, I will start with the smallest number. You go from right to left. Okay, 1, from the right, 1, it goes to 2, because the image is on the right. It goes to 2, then you have to jump and see where does 2 go. 1 goes to 2. Then you jump here, so 2 goes to 3. 1 goes to 2, where does 2 go? 2 goes to 3. So you put 3, and then you continue, you go back. 3 goes to 1. Bukan goes to 3 goes to 1. You see, 1, 2, 3, 1, 2, 3. 3 goes to 1. Where is 1? There is no 1, meaning 1 goes to 1. Remember, if there is no number, meaning it goes to itself. So 3 goes to 1, 1 goes to 1. So, oops, there's already 1 here. So you just close, because 1 is already there. What happened to 2? You can try. If it's not there, meaning 2 goes to 2, but we can try. If you want to see and make sure that you got the right answer, 2 goes to 3, right? 2 goes to 3, 3 goes to 2. So you will put, oh, 2 is already there. So you just do this. So the answer is 1, 3, which is exactly the same. This is very helpful if you have multiplying so many permutation. You don't want to rewrite in the matrix form. It will be consuming much time. Okay, I want you to go through some multiplication and examples yourself, but I want to introduce okay, there's some typo here. Product of permutation, page 111 here in my notes, is not commutative. Typo. This means the product of permutation is not commutative, not communicative. The line, third line, page 111, yeah? Not commutative. P1, P2 is not P2, P1, okay? Then there are more examples. Okay, this is very important. Disjoint cycle. Two cycles are said to be disjoint if no element of A appears in both cycles. Okay, two cycles are said to be disjoint if no same two elements appear in each cycle. Like this, 1, 2, 3, 4, 5. This is disjoint. You don't see any same numbers, right? Disjoint. If you have like 1, 2, and then 2, 4, 5, this is not disjoint. Because there is a 2, right? There is a 2 there. Disjoint and not disjoint. Theorem 3.1 is very important. A permutation of a finite set, which is not the identity or a cycle, can be written as a product of disjoint cycle. So any permutation can be written as a product of disjoint cycle. However it is, you can multiply and it will turn out to be a disjoint cycle. That is what it means. Okay. Now that is theorem 3.1. Any permutation of a length more than 1 can be written as the product of disjoints. Okay. This means less the length, like this is length 2, right? This is length 3. So what I meant here is length 2 or more. Length 1 is just the identity. And theorem 3.2 is the one I want to show you. Every permutation or every cycle can be written as a product of transposition. And what is a transposition? It's a 2 cycle. Cycle of length 2. Okay, I can say this is a 2 cycle or a cycle of length 2, a 3 cycle or a cycle of length 3. And the formula is that A1, A2, A3, AN minus 1, AN is equal to A1, AN. A1, AN minus 1. A1, A3. A1, A2. This is the formula. Okay. And as an example, I can write like 1, 2, 3 is 1, 3, 1, 2. 1, 2, 3, 4 is 1, 4, 1, 3, 1, 2. If you don't believe that, you can just multiply it again. 1 to 2, 2 to 2, okay, 1 to 2, 2 to 1, 1 to 3, 3, 3 to 3, 3 to 1, 1. So it's 1 to 3. Why do we want to write a cycle as a product of transposition? There's a reason. The reason is that if it is a product of an even number of transposition, it is called an even permutation. If it's a product of an odd number of transposition, it is called an odd permutation. So this is an odd permutation because it can be written as a product of 3 transposition. Okay, and thus there is an even and odd permutation. But you have to, before you break up, it has to be disjoint. Eh? Oh, well, wait, let me see. No, it doesn't have to be disjoint. It can be anything as long as, yeah, it's not disjoint, right? This one is not disjoint. Even in the beginning, doesn't have to be disjoint. Okay, last one is the inverse permutation. If P is this permutation, P inverse is the other way around. Okay. What does it mean by inverse? Inverse permutation means when you multiply, you will get the identity. That is why we call it inverse. So the inverse of the transposition is that transposition, right? The inverse of 1, 2 is 2, 1, which is 1, 2, right? It's a cycle, 1, 2, 1, 2, 1, 2. Okay. The inverse of 1, 2, 3 is 3 to 1 reverse, but this is also equal to 1, 3, 2 because 3 to 1 is 1, 3, 2. Okay, you can write 3 to 1 as 1, 3, 2 or 2, 1, 3, right? 3 to 1 or 2, 1, 3 or 1, 3, 2. Different times, but I normally will write the smaller number first. Okay, okay is the magic word. Okay, good. Okay, so I will leave the rest for you to try. Yeah, try all questions from chapter 2 relation and chapter 3 function. We will start class next week with a quiz. I will let you know the detail of the quiz and start with any question.